Hi, May.
Good morning, good evening, good afternoon, everybody. Hey, Keith, good to see you.
Hey, Greg.
It's been a bit.
Yeah,
So I think I'll wait pardon me?
Oh, no, go ahead.
I'll wait a couple more minutes before we get going. We'll see whether I should do some betting today. In theory, we have two Kens speaking today, so we'll see if that holds true.
While we're waiting, I have a question, and please tell me if we should move this to like Slack. Is it possible to do offline attestation of a trusted execution environment? So effectively, imagine that there is a trusted execution environment that has not been provisioned, does not have a line of sight to an attestation service. There is no nonce, but it can generate a quote, maybe generate its own random number, and then like do a quote over that. Has anyone tried it, thought about it?
So yes, the answer is yes. So there's no specific need for, I mean, for instance, an air-gapped attestation, right? So there's no need in most cases for the attestation service to have a direct link back to the silicon provider, for instance. So you always want it to be off the same machine, right? But there's no need for it to be directly linked to anyone else. Sorry, someone else was saying.
I was just going to say, are you specifically talking about generating the attestation evidence or verifying it?
I would like to generate it, but before I have a chance to go to an attestation service and get a nonce.
Yeah, so there's no need for a nonce for an attestation service. There's generally most attestation the actual verification doesn't require a nonce.
I think in my mind, the answer is, of course, you can generate the attestation evidence locally. The bigger question is, what's your overall scenario, and is there any requirement in that precludes that? So, for example, if you require a relying party that's not connected to be in charge of assuring freshness by generating the nonce, then clearly that nonce flow doesn't work, right?
Mm-hmm.
Yeah, the use case that we were looking at when we were in NOx was air-gapped attestation services. So the attestation service, which is doing the verification, has to be able to be contactable by the measurement if you want a a fresh verification, but it doesn't need to be done in real time. And you can always store attestation measurements for later checking. Dion has got a hand up.
Yes, I was going to note that it also, freshness doesn't matter if what you're measuring is the end of the computation. Say you're going from inputs to outputs, and you just want to say that you produced those outputs from those inputs in a trusted execution environment. This is something you would want to do in a build service, for example. You don't need freshness because it's useless at that point.
And I'm saying that existing attestation services and protocols today support this scenario, that I can validate this later. So basically, yeah, I generate a quote. It sits there, but somebody wants to know, yeah, okay, this computation took place in this trust execution environment, but it could be 10 years later, you know, like.
Yeah, that's good.
Okay.
To store the evidence.
Fun conversation. So anyhow, we are 5 minutes in. It looks like we have quorum, and I'm not going to go to Vegas today. Ken Gordon, who spoke last time, has a conflict, late-breaking conflict this morning, so he's not going to be able to participate today and do another round of Q&A on his discussion about the Azure Confidential Container architecture and policy language that he spoke of a couple weeks ago. But he can make it in 4 weeks, not in 2 weeks. So I'll put that on the calendar to have his follow-up Q&A in 4 weeks. And as for the agenda today, I see that there is 2 on the list. One was Ken Gordon, who's not here, and the other is CC-8 API with Ken Liu. I'm not familiar with that at all. So, that apparently somebody put that on the calendar, and perhaps somebody can give an introduction there, because I can't. Or if Ken, you just want to jump in, that also works for me. And I don't know if you go by Ken or Lou. I see there's a Lou Ken on the call. I assume that's whose name is.
Yeah, it goes back, and it's about like a general unified API for confidential containers attestation. Yeah.
Okay. Sounds reasonable to me. We have no other content, I think, for this week, for this session. So sounds very interesting to me. So feel free to dive in and perhaps take over the screen if you have some slides or something to share.
So, sorry, I'm Ken Liu. So now the topic is the first Ken Gordon or me?
Yeah, it's Ken Gordon couldn't make it today. So his topic will be, his follow-up Q&A will be 4 weeks from now. So the floor is yours now, Ken Liu.
Oh, okay. So I will present it now, right? Okay.
Yeah.
So thank you. So I will share my laptop. Can you see the top?
We can see the screen, yes. We can see your desktop.
Okay. Okay, so I will make the screen bigger. Yeah, so actually I work with Wenhui Haidong Jiewen on the proposal of CC Trust API or the CC API. Actually, we have already introduced this in CCC tech meeting in last year. So today we will update our current status for get more feedback. Thank you for your time to on this topic. The background, as you know, according to the TCD specification defined, so we a platform need to build end-to-end full chain management from the firmware, OS runtime, pre-OS module, OS runtime, and application. On the for the cloud native, for the cloud environment, the application is container or clusters, right? So under this event log, this evidence will be extended to individual PCR. PCR is platform configuration register for VTPM, and also RTMR. RTMR is runtime measurement registers in TDS, right? So they are all integrated measurement registers. So this event log will be extended to individual separate PCR or RTMR registers. And the sum of registers will be selected to create the code. The code will be signed, right? So some integrated register will be signed and general code. And then the signed code and with selected event log, because event log is, there are a lot of event log. So you won't send full event log to the attestation server, right? You maybe select some piece of event log related to your use case. So for selected event log and the code, signed code will be sent to the model attestation for local or the model attestation, right? This is a high levels process from measurement collection, integrate measurement register extension and code and attestation, right? So so today I will introduce the CC Trust API and the CCMP. So the CC Trust API is help to expose the runtime event log, the integrated measurement registers and the code for various TE, such as Intel TDS, such as VTPM, maybe AMD or others vendor, right? So, and also we introduced another thing called CCMP. CCMP is confidential cloud native primitive. So it helps to collect and calculate the measurement for the container, cluster, namespace. It depends on how you deploy your cloud framework, right? So for firmware measurement and event log, it can be collected by the firmware bootloader, and OS it can be collected by the IMA. It has been there for more than 10 years, right? So this is high level concept of work. Yep. Please, any question?
Yeah, I have a question, which is this: when we talk about these measurements here, are these of the host firmware and OS and CCNP, or are they of the guest?
The guest is within the TE guest.
Okay, so this is a VTPM measurement rather than the measurement in the of the host, correct?
Oh, it is something like VTPM.
I think there's a
within
confusion. Think of it as guest measurements, and how they're exposed could be through a VTPM or through, these RTMRs of Intel's TDX solution.
Yeah, okay, fine. But what I'm just checking here, yeah, this is helpful. Okay, but this is not measurements of the host system. This is measurements of the guest system within the TEE. Is that correct? That's really helpful. Okay, that's perfect. Thank you. That's really good. Thanks.
Yes, because in the computational computing environment, the host cannot be trusted. So we will not measure the host.
Exactly. That was my concern. If we were doing the measurement, I wasn't quite sure why. So this is fine. Thank you.
Yeah. So thank you for the question. This is very nice. Yeah. So as you know, for Intel TDS, right, we have configured TSM to expose the RTMR. RTMR is the runtime register measurement register, integrated measurement registers and code. And also you can get the event log from the ACPI table, the CC year for TCG event log, right? And for VTPM, AMD SEV and the Intel TDS both, right? So it will expose the TPM0 interface for PCR and code, right? And you can access the ACPI table TPM2 for the TCG event log. So different TE may have different access approach to the event log, code, and the integrated measurement registers. So we designed the CC Trust API is a high-level API to reduce access complexity and use unified API for across different TE. And so the API definition is follow the TCG because The event log format is follow the TCG. The integrated management register is follow TCG, and the code is binary blob, right? And we also implemented the Python, Go, and the Rust SDK, so the application can access the integrated management, event log, and the code across different teams. So this is original design purpose. And as we mentioned, the cloud native environment, the management is complexity. For example, the Red Hat define the computational computing use case, right? For computational VM, computational cluster, computational containers, either for computational workload. So for computational VM, normally your application will deploy within the VM and running on top of OS, right? So the management includes the OS management, of course, firmware management, OS management, right? Sorry, I missed the firmware here. So the OS will covered by IMA, right? And for computational cluster means you deploy your application within the node, and all node within the cluster will be deployed within one VM node, TDS VM, or the SEV VM, TE VM. So so for computational clusters within one TE VM node, you at least need to measure the OS and the container, but from cluster perspective, your application is running maybe depend on other service. So you also need to measure the other service because your microservice is not individual microservice. Others, such as Kubernetes, provided the etcd, provides the logging, provides the orchestrations, right? So all of these things is part of your pipeline. Your pipeline includes a lot of microservices. So it's part of the TCP. You should guarantee the Kubernetes should be measured, but it decided by use case. Maybe you can decide, oh, I don't care about other service. I only need to measure my container or my namespace, right? So the computer cluster is the complexity for the measurement. And for the computer container, here is a proposal. As you know, computer container is running a port in the VM, right? And within the port, it is a normal TDVM, includes the firmware, OS, kata agent, attestation agent, right? And your application will deploy in the code. So from measurement perspective, so you need to measure everything within the port to guarantee the trust, right?
Ken,
so,
may I
yep.
raise another question, which is we have
Yes.
a namespace clash here, which is that confidential containers, what they call a confidential container is a pod.
Yep.
However,
Yes.
the official naming within the Confidential Computing Consortium is that a confidential container is a single container image running within a single container runtime within a TE. And I just wanted to be clear about that here, because you're talking about a pod rather than a container. And I think I think we need to go to the TAC. I was talking to somebody about this last week, actually, and maybe work out how to regularize so we have the same naming.
Semantics,
because
yeah,
I think there's a lot of confusion that could happen here.
Very
I mean,
true.
my preference would be for what you call a confidential container to be called a confidential pod, because that is consistent. But between us, I think we're going to need to work out how to have the same naming. But I just want to be clear that this is not for anyone who's on the call who knows that there is this difference. We're talking about a pod here and not a single container image. Is that right? Yeah.
Yeah,
that's correct. I just think that for purposes of Ken's presentation, though, Ken isn't asserting that. It's just
no. I just wanted to make sure, and also to raise for you, Dan, actually specifically, that this is a piece of work I think we need to do either singularly or with the confidential containers project.
Sure.
Except cocoa's a very cute drink. Delicious.
Well,
cocoa might not sound so good.
Okay. Anyway, that's sorry. I just wanted for clarity.
That's fine. Yeah. Go ahead.
Thank you so much.
Yeah. Thank you. Very nice suggestion and clarification. Thank you. Yeah. So yes, as you've seen, there are a lot of different diverse various deployment flavors, right? So different flavors have different measurement approach, different measurement scope. So I mentioned we define the CC Trust API, which includes the default algorithm. For VTPM, the default algorithm is SHA-256, but for TDS it is 386, right? 84. And we also define some API such as get memory count, how many measurement registers. For VTPM, it is 24, 13 for launch time, and SRTM, SR static root of measurement, and 8 for runtime dynamic measurement, right? And for CC, we expose the measurement API for get CC measurement. So get individual measurement registers, integrate measurement registers. For TDS, it's only 4, but for VTPN, it has 24. And also expose the API get a CC report. So this is different. VTPM has VTPM code. TDS has TDS code, right? And SEV has SEV code. And for event log, it's standard. So because it is used TCG event log, so you can get whole the event log chain and select some event log to construct your attestation, right? You don't need to include all event log, but you need to collect all event log to make sure the integrity measurement is for chain extension. And also you can replay event log to guarantee the selected event log can be trusted with the integrated memory registers. So this is the whole API today. And for status, we developed the VM SDK and the container SDK. So to expose the same API in Python, Go, and Rust 9. And so in VM, so you can use VM SDK to get the measurement, get event log, I'm gonna get the code. But in the VM, it only includes the measurement only for the firmware and the OS node, because VM has no others. But for container, it will include the VM, the firmware, OS, and the containers. I will do a demo later. And from use case perspective, so today, as mentioned, we collect the firmware, OS we use IMA and the containers, and we have not created the namespace and clusters measurement, but we will plan in that step. And so with today's measurement, it can support the computational VM and the computational clusters to use case. And for containers measurement, we leverage the community patch. This actually provides the IMA template for each group, right? So yeah, I will show a demo later about the container measurement. Okay, so with this CC API and the CCMP, you can see what has been changed. Without CCMP, you can see this is the TD report. The TD report is the report structures for TDS. So in VTPM, right? So you can create the VTPM code based on the PCR and the report data. Similar concept, right? For TD report, it includes the TE measurement, the SIM module measurement, and the MRTD as the static measurement, and the MR config, and RTMR runtime measurement register, right? Runtime measurement register, there are 4, 0, 1, 2, 3, 4 runtime measurement registers. So without CCMP, you can see today, it only collects the firmware measurement. Firmware measurement is collected by the TDVF, the OMF, and the grab and the shame, right? So it will save the firmware TCP into the RTMR 0 and RTMR 1. If you have grab, the grab will be the first bootloader. So the OS kernel measurement will go to the RTMR 2, right? And with the VM SDK, so it sends the measurement from the firmware to the OS. So the OS TCP, OS measurement is done by the IMA, NIDA's IMA. So the OSTCB will be measured into the RTMR2. So, and with the CCMP, so extend the measurement from OS to the container. So because the TD report or the VTPM report is per VM, right? So for container and the port and the application measurement, it's not per port. So we will save the container measurement, application level measurement into the report data. This is similar for VTPM report data, right? So, so it means within your containers, you can create the TD report, includes both node level measurement and per container measurement in the report data. So this is how CCMP. Yep.
Okay,
Yep.
yeah. Did you use the report data field because you ran out of RTMR registers, or did you use it kind of for a semantic purpose? Like if you had 8 RTMR registers, would you put the container TCB into the report data, or would you put it into like RTMR, number 5?
Yes, the report data can be regarded as RTMR number 5, but the RTMR itself is per VM. In one VM, there are a lot of individual containers, right? For individual containers, it has their own report data. So it can be regarded as RTMR file, but each container has different RTMR file. It's per application or per container level.
Yeah, well, one of the things I'm thinking of is, I know I've run into different circumstances where different pieces of code, want to basically use that field for their purposes. So this seems, and this seems to put more pressure on this field. So I know it's not a specific problem of what you're discussing today, but it seems to me like that report data field is a field where I know, like in my experience in the last few years, there's been clashes where multiple parties want to use it, and then you kind of come into a design impasse where only one can use it and somebody has to give. So I don't know if that's going to affect this design or not, over time. But just my thoughts.
Yes, I think fortunately we can use it as an integrated measurement register, right? But for individual event log, so you can extend and save to the ACPI memory space. So for report data, it only saves the final value for integrated measurement, right? You don't need to include them. So you have some data, I have some data. We are all event log, and we extend it together and generate the final value, right?
Yeah, that makes sense, and I get it. I'm specifically talking about using that report data field in the TDX report structure, quote structure, that last arrow on the right side where it says goes into container TCB and the report data field. That report data field in TDX quote or any comparable hardware vendors attestation evidence seems to be at a premium. And I've run into, like I say, I've run into circumstances where, multiple parties are kind of at a design impasse because, only one party wins and the other scenario just isn't possible. So just.
Yeah.
Greg,
so
does it make sense to have some other data structure that we, like serialize and write to the event log and then pass the hash into that report data so there's some tie back, but we can share it better?
You guys are way more expert in this stuff than I am, and I'm just sharing the.
But I totally understand the contention for that one precious resource.
I'm just sharing that I bumped into issues with this field in the past, and I'm not happy seeing somebody else use it because it makes it harder for me to use it for my purposes. So I'm like, oh, you're making my life harder.
Yeah.
That's all I'm sharing. So if you can possibly go on.
The kind of the current thought process around report data was that the ecosystem would somehow agree to build an image that is represented by a single measurement, and then that measurement is provided to TDX report, to give it back and say, yeah, I checked this. This is the right measurement. But it assumes that the ecosystem somehow cooperates to say that here's one measurement that represents everybody's stuff. And so it sounds like you're saying, hey, that maybe works a little bit, but in practice, maybe it doesn't scale very well.
Yeah, I think using your language there, I think that, I've had at least one or two experiences where the body of code that's running in this protected environment has different folks, controlling different parts of it. And they basically want to, tell their relying parties, like, you can, this is the way to interpret report data. It means blah, 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 which is very specific to them. And so once you, in your container or in your VM, you have two or more parties trying to essentially, do that.
If we were to say overlay, say a co-RIM kind of construct, then there would be separate triples for each one of the components in this, and for this this different image, and they would each have different measurements that are identified as different things. And I think the question, maybe a broader question, is there value in having like a TDX root of trust that replays these measurements back to the environment, or is some kind of layering model appropriate, right? I think that's just an industry type level question where I don't know what the right answer is. It's like, if you look at DICE says, hey, layering works. If you look at the way TDX is designed, there's sort of a single root of trust. There's a single trusted component that plays measurements back to you.
Yes, but so in the TDX report today, we have node level measurement and firmware OS and for container, right? But finally, we will chain everything together to create the final chain measurement register, right? Hash, right?
Yeah.
So
yeah. The question has to do with, at the top of the chain, do we still want to have the notion of layering, right? And right now the assumption that the TDX design makes right now is that it's all one measurement, it's all one layer. But the reality of the ecosystem is there's lots of people in the supply chain, all of which want to kind of be in charge of their own destiny in terms of what components they build and release, and they want to follow their own kind of release process and not be dependent on each other to come up with one measurement for a larger image, right?
Yeah. At least for OS
fear
level,
that
right?
Sorry, I just feel like we might pull Ken off track into the topics that we often discuss here. And I'll defer to Ken, of course, but I think Ken might be looking for feedback on whether this part of the community sees value in the APIs that he's presenting, or whether you already have solutions that satisfy these. Feel free to recharacterize that, Ken. I just want to make sure you get the feedback that you're looking for in coming here.
Okay, so I will continue. So I will recapture the question later. Okay, so this is example for container measurement. So with the API, with the CCC Trust API and the SysMPs, you can see the event log here. So this is just follow the TCG spec. You have a special ID and header, and you have normal PC client format event log, and you have canonical event log for IMA. So this is the recent format to support the IMA, right? And for container event log, you can see the container ID and the port ID from the measurement, right? So we have two links. The one link is for event log collected from VM, and another is for event log collected containers. I will open the container here, so you can see an example. So the event log is long because they are include a lot of, not only the bootloader event log, but also the OS and the container event log in video, right? So it is a little long event log, but you don't need to send all event log to the attestation server. You can select some event log according to your business and create the final report data or final attestation data for attestation process, right? So this is so this is example for today, how the CCMP help to collect the event log. For VM, I will show a VM. For VM event log is simple. So the VM event log is not VM event log about. Yes, so this is VM event log. So VM event log is shorter, and it includes some pre-boot event log and some IMA event log. Yeah, some IMA template here. Event log. So for node level measurement, not only container level. Okay, so this is our example for node and container level measurement separately. And here I will show a demo, so you can get more insight on our work. So,
Quick question.
Yep.
Is it possible? sorry. To add other things that we might want to measure, like, so you had your VM launch and then maybe you have a special runtime, some special agents, whatever. Will this API allow end users or even container measurers or cluster measurers to say, please measure this, this, and that?
We do not trust any agent. We just trust IMA because IMA is in the kernel and the kernel will be
I don't want to
firmware,
trust the agent, but I want to measure some additional things. Like I might have a VM, with Ubuntu, whatever, but I have some other agents and things that I want to measure. So can I control the measurements of those?
Yeah, policy. This is policy. What you should be measured, right? I will do a demo and it will show how to modify the policy to measure some specific OS level application or some containers. Or Kubernetes. Okay, so I will show the video here. So I may not play all, and we are quick. So in the cloud native environment, so the first step is that we deploy a CCMP service as a demo site on the clusters, which will be help to collect the evidence for cloud native. And so then we use the kube control to enter the containers and to check how the container was measured. So then within the containers, you can run ccmeasurement.py. It show how to use these tools. Within the container, you can get a CC report, CC event log, measurement, and verify event log. Use the replay approach. So yes, within the container, you can dump all event log from the node level and to the container levels. And I will skip this. This is very simple. Here. So we provide a template policy here. You can customize IMA for process levels measurement, or you can configure. You can measure some config file, or you can measure some port. Or you can measure some applications, right? So with the policy, you can customize IMA to measure different things. There are two things. The one is system level. System level means you can measure some application or config file. For Kubernetes levels, you can measure some port and some config and port, right? So this is policy, Manini. Did this answer your question, Manini?
Yeah. How do I pass in this policy?
So it is part of CCMP containers. Because CCMP container itself will be measured by IMA. So if you change the policy, the trust chain also be changed. The measurement chain also be changed. Okay. So, okay, so I will skip others because it will it just introduce how to get the content ID and the port ID from the event log. So you can choose some because event log there are a lot of event log. So you don't need, you maybe choose some of them to construct your attestation object and do, yeah, here also you can dump the integrated memory registers and you can use replay to guarantee the whole event log can be replayed by individual integrated memory registers. For VTPM, we have 24 PCR registers. For TDS, it has 4 registers, but only 3 can be used. The RTMR 3 is reserved. So yeah, so but someone such as Constellation will use RTMR 3 registers for cluster ID to save the cluster ID, right? Yeah, so I will skip. So yeah, so they are all the content level measurement. I will skip. Yes, okay. This is all of my update today. So is there any question or is there a suggestion?
Yeah, I've got another question, if I may. So, a bit of explanation for the question first, which is that one of the things that this says to me is that we've got rather a big TCB, right? Because if we didn't have such a TCB, we wouldn't be worried about measuring it. And one of the good practices of security is minimizing your TCB as much as possible. So, which is kind of one reason for not having an entire pod in a TE, but that's a design decision. So I think the question I have is, alongside this work, is there any work to reduce the TCB as much as possible by actually cutting code? Because that's going to be running inside the TE, because from my point of view, that would be equally beneficial, if not more beneficial, than being able to measure a test. So cutting down to TCB is absolute to the bare minimum. Seems like a good approach to be taking. Do you have any thoughts?
Yeah. So for small TCB, for example, either you can put your application within the firmware, right? You don't need OS. OS introduced the big TCB. OS has kernel, has grab loader, right? So for TDCM or SVSM is AMD's firmware, right? Simplified firmware, and TDCM is Intel's small firmware, right? You can write your Rust code within the firmware, either for OMF, then you can reduce the TCB much without OS. But if you need OS, then OS is a big TCB, right? And you need because OS is in the TCB, at least you need a measure, right? Otherwise, you lost the measurement.
Yeah, so that's the problem. You have a big guest OS. Can you cut it down or can't you cut it down? And I would say that if you're going to take this approach, there should be, my personal view is that you should try to have as cut down a version of everything you need, the OS and container D or whatever you're running inside it as possible, and that would certainly be something that I would be looking at as part of that contract.
And I just want to add that Intel is looking at that. So they have a library OS called Grameen, which is also part of the CCC consortium, and there are efforts to make, is that library OS adequate, and can we run your workload with that? So there is such an effort.
That's a great thing to hear, that's being considered as part of this project. That makes me very pleased. Great, thank you.
The other thing, though, to think about is when you're also talking about environments, and so you take the example of, say, hey, I can take a bunch of OS stuff, which is normally protected by ring 0, and I can use a live OS to take OS stuff and put it all into ring 3. You might not have better security. You might have smaller code base, but you've conflated everything into one environment, which doesn't have any firewalls.
So again, it depends what your threat model is there, and so understanding
Yeah.
the threat model is very important in this context.
Yeah.
No, I
Super.
100% agree.
Yeah. Okay.
Yeah. Yes, and think so. Your application may be deployed within the TDCM, or in the firmware, or maybe in the VM, or maybe in the computer container or the computer cluster, right? So that is why we need a unified API. When your application deploy in different environment, you can use unified API to get the measurement, to get the code, to the report, right?
And I think that's an important part of it, right? Unified API is all that this is about, as far as I understand, right? Of course, we all agree that a smaller TCP is great, and I think we security folks also tend to argue for a smaller TCP. But I definitely appreciate that whatever people do, this enables them to have a unified API instead of having a different solution for every single individual size that they decide their TCP to be, right? So I like this, and I will also look at this more to figure out whether this can be useful for us, or whether we can see what to do with it. Because yeah, I think unifying things is always great. So I think it's cool.
Thank you very much. So
Hey, I have a question.
Yep.
What's the current status of like deploying CCNP or CCAPI in major cloud service providers? Or are there any challenges, blockers, or you can use directly with confidential VM provided by cloud providers?
Yeah, this is a nice question. So today, at least here, we implemented the VM SDK and the container SDK, and support the container VM and container cluster use case. But today, the unified API can support the RTMR and the VTPM, right? But we only implemented the RTMR approach. VTPM is still in working progress. So if we deploy the CC API on the existing clouds, such as Google, such as Azure, such as others vendors, right? At least you need to support the RTMR firstly. If you have no full RTMR support, then the CCPI cannot use. But if you have VTPM, of course, CCPI can support VTPM, but it's still working in progress. And if you have both RTMR and VTPM, right? CCPI is a good choice to support both of them, right?
Yes. Okay. Thank you.
Yep.
There are quite a few of these libraries and solutions out there with different formats to carry the evidence. I think that we're going to try to want to trend towards standard formats. Or do you have in mind an EAT or the CMW format to bundle all of these event logs and evidence together?
Oh, you mean how to bundle all event logs together, right?
Right, because like the confidential containers guest attestation daemon, the GoTPM tools, the Verti project, everybody packages up all of this information in whatever bespoke message they want to. And the standards that we're seeing coming out of IATF are trying to get folks to use certain envelope formats like the conceptual message wrapper, so that you can have your evidence, you can have your collaterals, say certificates that you can forward along, so you don't need to reach out to a provisioning service, etc.
Oh,
I know that we're planning on using that for GoTPM tools, or introducing it into some other evidence collection tools, so that we can use standards.
Yes, I think this is a very nice question. So, I think so. Today, our API is belong to the fast computing group. It is along with the TCG log. But you mentioned IETF create some pack attestation format, right? So it is high-level API control, high-level standard controlled by IETF. So I think for CCPI may not able to today only comply with trusted computing or TCG, but and I think if everyone can contribute, right? So that's why we create the CC API, not a trusted API, right? Not trust only API. So we can extend the IETF spec to this API list. I think this is a really nice recommendation. I think.
Okay.
Yeah. But at least we firstly need a unified API to collect evidence. Then we think how to package the evidence in unified format for attestation as the next step, right? Do you agree?
Mm-hmm.
Yeah.
So I think maybe another way to look at it is at the quote level, the layer below where you have the TCG stuff. There's going to be formats, quoting formats that some are proprietary, some are standards based, and whatnot. But an API is going to need to essentially support all of the ones that are relevant for some period of time until the quote formats are all standards based. And so I think, it's maybe fair to say that Intel has a roadmap for producing standards-based quotes, over time.
With respect to the CC API, right, the format of the event log seems to be owned by the API, not by various vendors. What level of standardization has been included with respect to the event logs themselves, and could that be applied to CMW?
Those are just going to be specified by content type. So whatever format you're going to be putting into the CMW, you associate with a content type that says basically what format it's supposed to be in.
So for example, IETF is working on something called conceptual message wrapper. It's essentially a way to tag what the content type is for whatever format, proprietary, standard, or otherwise it is. So you're sort of, it's a way to preserve the quotes and other information that are collected from beneath. It's a standard way to preserve them and mark them as it filters up through the layers to the top. But I think maybe the observation is it would be nice if the industry could rally around a few of these standards and sort of minimize the complexity of having support, a mass number of them.
I've got a question if there's a lull here. At least from my interpretation here, the APIs in this scenario seem to be centered around producing attestation evidence reflecting this measured environment. Is there anything in the APIs to support the verification process? So somebody eventually gets this attestation evidence, be it a verifier or be it a relying party, and has to basically, determine whether they trust it and extract some fields. Is that part of what the APIs intend to handle? Is that in there and I just didn't see it or something? Or
yeah, so today, so as mentioned, so the CC Trust API, actually CC API is not a good name. CC Trust API only to collect the trust measurement, and evidence. So for attestation part, so it's not, but I think we can create the initial API in CCC firstly, then we can, everyone can contribute any proposal, right? But maybe we can have CC Attestation API, not Trust API separately.
yeah,
Do you agree?
I guess I would just reflect that least as far as I know, attestation scenarios aren't complete until somebody consumes the evidence and takes some action based on it. So it seems like if we need both legs to kind of complete scenarios.
Yeah.
So, and just as a reminder, CCC has, had other speakers talk about, APIs for things like Verizon that does some of that.
Yeah, and I work on a verification survey. So when I look at something like this and I imagine getting this evidence, it's like where I want to start with is an SDK that understands the format that's being presented, right? That's the typical place to start. So versus, here's just start writing code from a binary structure that you reverse engineer, or there's some document, or look at some Go code that created or something. So it's that's where I'm coming from.
So we have to think of names. Would it just be better to have a CC API and then there's one to parse out attestation stuff without having to get into the binary, one to measure stuff, and then maybe one even to force measure of other stuff. So it doesn't always have to come through a policy.
Are you asking me that question?
Yeah.
I didn't 100% understand your question.
So like we
Go ahead.
called it CC Trusted API right now.
Mhm.
Should we just have it called CC API, and they're like subgroups of APIs, one for the attestation comprehension of the blob that you're getting and retrieving things from it, another one for this measurement phase, like an umbrella API name.
Yeah. I'm less concerned about the naming and the grouping. I'm more just asking questions about
To
the
have it.
content, and
Yes.
and
Okay.
I'm just not seeing the full scenarios complete unless all APIs exist, or it'll be harder if
Mhm.
code that's trying to verify doesn't have some helper APIs to help parse the evidence and things like that. But certainly the more structured, as you suggest, with different categories and areas to look for different API types, is helpful. Absolutely.
I mean, this talk seems to be focusing on the container as the attester. There was no discussion about the container as, or a pod manager as the verifier or reliant party. So it just seems like this talk wasn't sort of aimed at that other question.
I think that's fair. There's an attester surface. And so for those of you who have already productized that kind of surface or in the process of it, would you replace what you've done with this API? Would you, if you haven't done that, would you select this API rather than what path you might be on now? Maybe slide 6 would be, I can't remember which slide actually has the APIs on it. Yeah.
This page, yeah. So what's your question? Sorry.
No, I'm just asking the community here for the feedback
Okay.
that I think you're looking for, which is this project is providing a few different things. Amongst them is this set of attester APIs. Do these solve problems that you need solved?
I think there's a bit of a.
Go ahead, Dion.
I think that there are some difficulties in flexibility when we're trying to solve problems that don't necessarily fit the API or have any standards just yet. For example, the ACPI tables have a large set of possible values in the whole of compute engine. And in order to generate them ahead of time directly from source, we would have to run a compiler at the time of starting a VM. So we don't do that. We create templates of ACPI tables and then populate them at time of VM creation. So if we were to, and we don't right now, if we were to measure in the ACPI tables into PCR0, then there wouldn't be enough information in our signed values because we'd have a signed template to reconstruct what that expected digest is. Right, so we would need to be able to collect up certain offsets within the ACPI dump as part of the evidence. And that's kind of weird, but that's an example of the kind of platform-specific weirdness we might have to think about before locking into a minimal API like this.
Excuse me, I'm gonna jump in here. We're out of time. It's 10 o'clock. And I know probably lots of folks have other meetings they need to get to. Ken, so thank you very much. This was I know for myself personally, it was an absolutely fascinating discussion. And I'm sure I personally would have at least one or two more questions I think about in the next few weeks. It doesn't sound like we're complete with questions. Are you able to come back in a couple of weeks and perhaps finish up the Q&A?
Yes, of course.
Great. Thank you very much. So let's plan for that.
Thank you, everyone.
Okay.
Thank you.
Thank you, everyone.
Brilliant, really interesting. Appreciate it. And it's 6 o'clock, not 10 o'clock. I don't know where you're getting that from.
Can you share the slides, please, also?
Yeah, please share them. Thank you very much.
Yeah.
Bye.
And
Thank you.
chairs,
Bye.
co-chairs could stick for a minute, and let's make sure we got coordinated the next meeting. So, Keith.
Yes, I've missed a couple. I think I'm due. I can share the next.
Yeah, although I think Thomas may have already volunteered for it. I can't quite remember. But Thomas, is that true? Did you volunteer for the next one because it was somebody you knew or something, or?
Yes, I know. There's Tyler from Red Hat presenting the key broker, isn't it? On the 7th of May.
I don't. I'm impartial to who chaired it, just to make sure that if you had that expectation, it was still honored. I don't recall.
Keith wants to take it. I'm all for leaving it. It's last time it was just I think Keith was not there. That's why I took that.
Okay, Keith, you got it then. If you're okay
All
with
right.
it.
Sounds good.
Okay, great.
Thanks.
Talk to you all in a couple of weeks. Okay.
Bye.
See you.
Bye.